This video is a high-level overview of Kubernetes. Kubernetes has gained popularity over the last several years and continues to grow day by day. It was born out of the vast experience of Google running applications at massive scale. It is an open-source container orchestration and management tool designed to automate the deployment, scaling, and operation of containerized applications. It has the ability to support hundreds, thousands, or even millions of containers. It is runtime agnostic, meaning you can run Docker or Rocket containers together. Before really being able to understand Kubernetes, however, we must first have a basic understanding of containers. So what are containers? Before containers, we had virtual machines. Virtual machines allowed you to run a guest operating system inside a host. For example, you could run Ubuntu inside Windows, but you must pre-allocate hard disk space, memory, and a fixed number of CPU processors to it. Containers, the most popular framework being Docker, was born out of a concept from Linux called LXC, or Linux containers, which allowed developers to bundle application dependencies and libraries how a virtual machine would. But the kernel would be able to decide how to allocate RAM, hard disks, and CPU processing power dynamically to each containerized application, rather than giving them a static amount of any resource. So what can Kubernetes do? Kubernetes allows you to schedule and run application containers on clusters of physical or virtual machines. It allows you to move from a host-centric infrastructure to a container-centric infrastructure, which really provides the full advantages and benefits inherent to containers. A summary of benefits include co-locating helper processes, mounting storage systems, distributing secrets, checking application health, replicating application instances, using horizontal pod auto-scaling, naming and discovering, load balancing, rolling updates, monitoring resources, accessing and ingesting logs, debugging applications, and authentication and authorization. So how does Kubernetes compare to its competitors? The first competitor, or not really a competitor, but something similar, is DCOS, or the Data Center Operating System. It is similar to Kubernetes, but it's different in that it targets many different workloads. For instance, it can run both containerized and non-containerized applications. This is advantageous to companies who are not using containers for all of their apps. You can even run Kubernetes on top of the DCOS. Or the EC2 container service is Amazon Web Services' version of a container orchestration tool. It has a limited subset of features, but it is useful to those who are already deeply invested in the AWS ecosystem. Docker Swarm, or Docker Cloud, is the official orchestration tool from Docker. It's similar to Kubernetes in that it has this concept of stacks, which is pretty much analogous to the concept of pods. It also works natively with the Docker CLI, and it works seamlessly with all the tools in the Docker CLI toolkit, including Docker Compose. So ultimately, the question you may be left with is, why should I choose Kubernetes then over the competitors? And I hope to enlighten you further with that with my next video as I go into more depth on what makes Kubernetes a great tool to learn. This overview has highlighted some of its key points, and its ability to be container runtime agnostic is a huge plus. The fact that it simply was built by Google is also a testament to it being of a truly battle-tested nature. Very few companies can claim to reach the scale that Google has. Kubernetes has proven itself to be a viable container orchestration and management tool, and I hope this video has piqued your interest and made you want to learn more about Kubernetes.